So, welcome to the last talk of the day. Thanks for everybody still coming here. I know I'm the last one between you and the beer. But we shouldn't finish early because I heard the beer is only cold after 5. So, topic of today, the last talk, the monolith must die. That is my first promise. Second part, how to convince managers. This is the second promise. I will only fulfill one of them, I can already tell you. What do I plan for the next half an hour? I would love to start with a question of what is actually a monolith, because I love to start with what do we actually want to do here. I would love to continue with when do we need to change actually. If we got there, how can we convince people that we want to do that? If we have convinced people, how would we do it then? And the last one is an example. Let's see how it goes. For context, I'm Anja Kunkel. I'm working at Mr. Specs. You see it bottom right or at the back of my shirt. It's unfortunately at the back, so you don't really see it anywhere. Anyways, let's go. Let's start with a quote. And a quote by someone I love to quote because it's so famous that I don't have to defend what he says. So, what is a monolith? A monolith is a single logical executable. That's super easy and super nice. And if I go for that quote, I immediately have one question. What is a single logical executable? Because define one thing by another thing, not helpful. So, Martin Fowler has a second part to that, and that is a single logical executable happens if any changes to the system involve building and deploying a new version of the application. Yeah, okay, cool. Now we have a definition of what is actually a monolith. And now I come to the part of why do we have a problem here. I said the monolith must die, but how do we want to kill that thing? One thing is we can delete it. Okay, but then the whole use case is deleted, and if we delete the whole use case, we probably have to convince business people to kill their business. That might be the wrong direction. The other option we have is to split it into pieces. That's what usually people are talking about if they are talking about monolithic applications. But, okay, I split it, so afterwards I have two things, but what are those things? Once again, logical executables, so monolithic applications. By going by Martin Fowler, the whole discussion is ended here, because a monolith cannot die. That's what I just said in the beginning. This is a promise I cannot fulfill. We cannot kill that thing. But what we actually want to discuss is a different quote. And the different quote, once again, Martin Fowler, but it's more helpful. And that is, the term monolith has been in use by the Unix community for some time. It appears in the art of Unix programming to describe systems that get too big. So it is not about logical executables, actually. That term is used to describe systems that are too big. Okay, cool. This is what we actually want to talk about. This makes sense. All fine. Now, still being super logical, the term says it's too big. What is too big? So we need a graph, something with a scale and something with a different scale so we can actually work on it. Something is getting too big, so we need the size of the executable as a dimension. And too big is problematic means probably we have the number of problems as the other scale. And what we all perceive all the time is that if that thing is too big, we have too many problems. That's what programmers are complaining about. Got it. If we have a smaller thing, we're more on that dream island. Also nice. Yes, I don't want to put exact dimensions here because this will not work. But this is actually the goal of what I want to talk about. How can we get from the bottom top right, that's dangerous, a bit more to the left? And for that, the first question is, what are the problems that we have on the top right? Because I have to be honest, I don't like complaining just because I don't like code. I don't like that code, yeah, okay, you're bad. We need to have real problems, obviously, to solve. So, going for the dream island, I chose sharks as our problems for today. And I've brought 3 of them with me. The first one I want to talk about is build and deploy time, because that's the one that usually people talk about if they complain about monolithic applications. Long word. What's the problem with that? Obviously, yeah, it takes longer most of the time. First admittment, it doesn't have to. If you do it really well, you can still have fast builds. So things just statistic-wise, a lot of people don't have them if the application is super big. What is the problem with having larger build and deploy times? I see 2, except from it doesn't feel good. One is it's actually harder to work test-driven, because if your tests run for 5 minutes, you don't want to wait for them. You just work in a different way. So you build huge stuff before you test anything. This is true if I'm talking about unit tests, but it's actually also true if I'm talking about like features. If a small feature takes me a long time to test, I build a bigger feature. So it's harder to work agile with a too big application. So that's why build and deploy time can be a real problem. Second part is ownership. Once again, it doesn't have to be a problem, but usually it is. Because if that thing is huge, nobody feels responsible for the overall application anymore. Most of the time you have multiple teams on it. And most of the time they just have their parts that they feel responsible for, and then there's middle ground that nobody feels responsible for. That's what I've experienced with all companies where I've seen monolithic applications. Problem here, if you don't have owners for parts, you don't have people feeling responsible, it's harder to do that and so on. And other problem, autonomy. I will come to that in a few minutes. Last part is probably the most obvious one and the most, let's say, operational one, scalability. I've seen a talk by Urs 2 hours ago talking about you should only scale if you really need to. That's nice, but now scaling is expensive if you have a huge application. Only if you need to, sure, but now you have to duplicate that whole thing, so it's not like, okay, the small part that has heavy load, I can just scale up. I have to scale the huge thing. It just costs money that you have to spend here. Plus, what sometimes happens, if it costs money, people want to avoid spending money. Makes sense. So what is the alternative? You optimize instead. If it costs money to just run that application with more servers, you start to optimize your code. And often enough, you over-optimize. It gets super complex because you want to avoid having more servers. So, I forgot my animations, sorry, I have to skip them. I have to be honest, I just talked about top right side, but in this graph I have something that I also want to mention. I'm not the biggest fan of super small services. I'm not a huge fan of huge monolithic applications, but also on the left side there are other problems. That's why this graph also has a left up. Not as high as a right up, that is my personal perspective, but there are also problems on the left side. And I want to quickly mention them. I see 2 parts here that are the most critical for me. First one is fast computation. So, that is really if you go into nanoservices, kind of a swear word. Means obviously your code is faster if it's running in one instance than if you have to call the network for the next 2 lines of code. Second part, the independent changes, meaning if your code is split into very small parts, usually every single feature touches multiple services or multiple applications. And that means it's actually hard to coordinate changes at some point, because you always have to do, okay, first application this part, second application that part, then I adjust that one, then back to the other one to get the feature done, and so on and so forth. This is also not very cool. Plus, if you ever find out that you split those applications wrong, it's harder to change that because it's, once again, first the one part, then the other part, and migrations are hard and painful. It's easier if you have a monolithic application, so you're moving something from package A to B, if you want to move at all. Okay, so far so good. I've talked about the left side and the right side, and I hope you agree that the goal is in the middle. We don't have to put exact values on the scale, but the goal is on the middle. So we know the goal, we know which island to go to, but how to convince the crew now. Let me phrase it like that. We as the developers have our goal, we know why it's painful how it is. But what I've seen all the time is now the business people come, why should we invest money in that? Why should we do that? You're complaining, but maybe you're just whiny. And I mean, I get it. Business wants to earn money, not really wants, needs to, because they need to pay us and other stuff. So they want to have something that brings money short term. All the stuff we are always telling, yeah, monolithics are not that cool, is long-term stuff. It rarely brings value very short term. So my next part is, which arguments can we use, at least sometimes, if we want to convince business people that we need to split a monolith? I have one big solution to that at least for me, it already worked 2 times. I don't know if you tried. And that are the DORA metrics. So the Google Cloud DevOps Research and Assessment metrics that they found. There's one great book about it. You see it in huge size over here. So that book, Accelerate, Building and Scaling High-Performing Technology Organizations. And the title actually says what it's about. It's a lot of numbers and studies, but it's not only about, yeah, we want to have it cool, but also it is scientifically based on, there's a correlation between technology improvements and organizational improvements. And that is the interesting part about the book, because we want to have nicer technology, but it only brings value if the business gets something out of it. So that's why this quote, that for me summarizes very well what it's all about. And the quote is, we found that where code deployments are most painful, you'll find the poorest software delivery performance. So far, so understandable. That's what also our gut feeling tells, but now it's getting interesting. You'll find the poorest organizational performance and culture. And this is the part that's actually more interesting to me, because organizational performance in the end translates to money. What did the people in the book do? So just that I put the names at least once. The studies are mostly by Jess Humble and Gene Kin, and the book is also together with Nicole Forsgren. They have a lot of numbers about correlation, not causation, between better performing operational systems and better performing businesses. You find all the detailed numbers in the slides, and it's actually, let's say, dry and hard to read, but very interesting what's coming out of it. So, what did they do? Let me grab a bit of coffee, and then we go into the metrics. There are 4 metrics in that book. I have to add, they do studies every year, and since last year there's a 5th metric, but it's not part of the book. That's why I ignored the 5th one and stayed with the 4. The 5th one will be reliability, but let's stay with those ones. So the first one is deployment frequency, meaning how often is something successfully released to production. To give you a gut feeling, they started studies with worse means like less often than a month. And you're good if you're at multiple times a day. Second metric is lead time for change. The amount of time it takes to take a commit to get into production. I believe this metric is questionable because it only starts with a commit. There's a lot of stuff happening before people actually commit code, but okay, this is a DevOps metric, so fine for me. So between commit and production, whatever happens with a size, if it's a branch, deployment, whatever. Once again, you're good if you're more in days than in weeks. But there are also big companies that have to talk about months or years. Third metric, once again interesting, change failure rate. It's kind of a counter metric to the first two, because you can easily optimize for the first two by just coding, and deploying. Now the third one is coming, so the percentage of deployments that create failure. Failure, not that precisely defined, but take it as bug or system down. So the goal obviously was not to deploy, but deploy meaningful stuff. And the last one, once again, I said it's more operational focused, is the time to restore services. So how long does it take to recover if something failed? Once again, that can mean service down, but can also mean how long does it take to recover from a bug? How fast are you getting the bug out of the code and gone for the customer? Here we go. So, yeah, those metrics are nice. It's an interesting book. For me, the critical part is I have my monolith. How can I use those metrics to convince anybody for anything? Because otherwise, it's not helpful. And for that, what I will do in the next minutes is I take every single of the metrics and sharks that I find most interesting and will combine them for you, how I have seen arguments and discussions, how they are connected. And I hope that you can take one or two out of those combos and do the same. At least that's my goal. So we start with the deployment frequency. And I've said that that build and deploy time is a regular problem with two big applications. Why is it a problem? For deployment frequency, I might say it's obvious. If it takes longer, you cannot do it as often. That would be the very obvious connection, but usually build time is below days, so you would still be good, even if it takes a day to build. I believe there are two other ways that I've seen how they are actually connected, and that is, if build is a pain, you avoid it. We are all lazy, and if it's painful, you avoid it, so it means you build bigger chunks and you don't deploy everything all the time. If I have pipelines where I have to wait for 2 hours to get something, I do other stuff in the middle and don't deploy. And then I forget my button and whatever. So I believe there's actually a psychological topic in the middle. If the build time is more than a few minutes, that regularly happens, why you get less features out. Second part, if that has happened to you, what I've also seen is people start to bundle their deployments. Like, okay, it's painful to deploy every change, so what do? I wait till a few people have that, and then I deploy. Seen that with nearly every big monolith that I've worked on. Why is it a problem? The deployment frequency goes down, means the first feature that came in takes longer till any customer sees it. If you then start, like, okay, my bundle deployments are a pain in the ass, I schedule them, you're really more in the world of bigger software. And that means it takes even longer to get your features to customers because, I only deploy 2 times a week. My feature was ready on Friday, but the next deployment is on Tuesday. You're bad. Here we go. Next one. The lead time for changes. It's something where I have the feeling that it's way more understandable for managers than deployment frequency is. Because they don't really care how often we deploy, they want to see features. So this time it's 2 different charts. The first one is once again the build and deploy time. Because obviously, the first thing that happens is if you deploy less, seen on the last slide, it takes longer till the change gets live. Okay, same argumentation, I don't have to do it again. But there's also a second part to it, that part that I already mentioned in the beginning. You start to build bigger increments. Also, I know that my whole deployment process sucks, so I don't do a small ticket with the first test. I do a big ticket, because if it takes a week to get it online anyways, I can do all the work at once. So it takes longer. If you do it like that, what I've seen is usually you have to coordinate with more people, because all your huge merge requests now have to be put together. So it takes even longer. That's what's happening here. Obviously, you have to turn it other way around if you want to argument against a monolithic application. So if you want to get the lead time down, you have to go in the direction, okay, then we need to get the build time down to get all those implication lanes, lines of argumentation away from you. Next one. 1 second. Ownership, my personal favorite. Why do I see a connection between ownership and the lead time for changes? What I see is actually, if you don't have really ownership, because you only have that small part in an application, if I find out, okay, the whole deployment process or whatever sucks, I cannot just change it. I'm dependent on the overall system and the overall setup, so I don't have the autonomy to optimize my work. So even if I want to, I cannot work on the lead time for change often enough. So let's continue with the next. By the way, if you have questions on understanding how I try to connect it, you can also put questions in the middle or later, as you like. But I try to see it. And luckily in this room I would notice. But okay, let's continue. Change failure rate, so meaning how often do we have problems on production? The first one, once again, the deployment time. I would have to repeat the arguments from last one. So larger deployment time tends to lead to bigger increments of software, because you need all that cycling anyway. And actually the bigger increments have a tendency to contain more problems. That's just how it is. It's harder not to make a mistake if you build a huge feature. Second part. No, I forgot some animation, sorry. Once again, the ownership. This time not so much about autonomy, being a part of ownership, but more about business ownership. From my perception, having no ownership means also you don't really have a full domain knowledge. If in a huge application, most of the time there are parts where nobody has a full overview how exactly it shall work. Most of the time there is some parts that really nobody has a feeling. So nobody knows fully which problems are to avoid, so there is just a higher risk of making a mistake. It's way easier if you have it at least cut into pieces, because then you know at least the borders of where it might fail. In a bigger application, if it's not super well structured, the risk is increased. Let's go to the last metric, meaning the time to restore service. Where do I start? Once again, the build and deploy time, because it's always the first. This time, once again, only a trivial one, so it's not the best argument. I wouldn't recommend to use this argument. It is. If it takes long to build and deploy applications, it also takes long to to get a fixed bug into production, just because you have to build and deploy it, obviously. As I said, this is not the best argument, because usually this is not your real problem. What for me works way better is actually the ownership part. Once again, this time I just said business ownership help is needed to understand what's going on. Also, business ownership would lead to monitoring of what's going on. And time to restore a service does not only mean how long does it take me to fix a problem, but also there's time included how long does it take me to notice if I have a problem. That's also part of that metric. And for me, increased ownership would mean that I would have more monitoring, so I would notice faster if I have a problem at all. Once again, it is not true in every application that you have just because it's too big, but it's way easier to think about proper monitoring of applications if they are well scoped than in a huge application. And last part, it's more for completeness, scalability. If your big services take forever to start, thinking about Java, some of the Java applications that like need half an hour to get their cache and everything warm, it obviously takes longer to restore services after they were down. That's also not the critical path most of the time. So the critical out of those three is, for me, is the ownership part. So how good is the monitoring? Let's finish with this whole discussion part and how can I put the arguments together. So we said we want to go to that island. We have understood which sharks there are by now. We also convinced the crew that we want to go to that island, hopefully. So now the question is, how do we get there? Why they still have, yeah, okay, it's nice that we get there, but it's probably too expensive. So they might not be 100% convinced. Part here, now it's really getting into if you have convinced people what is the approach to choose. I don't want to go into all the details because how to split a monolithic application, there are other people who have spent hours to talk about that and days. So I don't have to do all the details here, but I want to at least recommend a path. So if you don't know it by now, you have at least a starting point. Important for me, please don't go for the big rewrite because that is expensive once again. So probably hard to convince people, but what might work is go for something more Strangler Fig pattern style, once again Martin Fowler, so meaning cutting out smaller parts and enlarging them on the way and killing the original application by moving everything out of it. What is the full quote? Hopefully helpful. It's the most important reason to consider a Strangler Fig application over cut over rewrite is reduced risk. A Strangler Fig can give value steadily, and the frequent releases allow you to monitor its progress more carefully. The critical part out of that quote for me is reduced risk. Because if I manage to convince a business person, yeah, that whole thing is not cool, it will be hard to tell them, okay, we need to work on this now for 2 years. And they will not trust the 2 years, so they will believe it's more 5 years. So why should they spend all that? If you can offer something like that, yeah, we have to start on it, but after 1 month you get the first small benefit out of it. That's way less risky for them. Also because they still have the chance after a month to tell you, okay, we stop here. So this is a way where I see a better chance to convince people. Worked at least twice in my experience. What I wanted to provide you next is one example how I've seen it in the company I'm right now working for. Once again, not in all detail, but what we have at Mr. Specs is we have one monolithic web shop. Made sense as the company grew. You should always start with a monolithic application. So we have a shop. It contains quite some domains. I just take a few standard web shop components now for the explanation. So meaning we have products, we have users, we have checkout, and we have a content management system for the pages. All the stuff you usually have in a web shop. Nothing special so far. As I said, in the early on it was nice, then you build features, so now you have to start cutting that thing. How did we start? The first decision was we want to go for the product browsing or product search part to cut that out because it's super relevant for the customer, so it brings value fast. Don't cut out something that nobody needs anyway. Oh, okay, you might want to go for the deletion part then. So, product search, the decision here was we start with the front end and cut out the front end, but leave all the back end where it is. So we started with a super small front end, meaning we took exactly one page for exactly one product category. So Mr. Specs is selling glasses. We started with the accessories, so the laces for your glasses, because it's the very smallest page that we have. And everything else, build an API and ask the old system. From there, we were able to iterate and put more in the bottom part. Not only the accessories, put the real glasses, put the contact lens, put all that stuff that you have. And then we were able to go for the back end. But for the first part, so only moving out the front end, what were the arguments that we actually used? We had 3. The first one, the old page is super slow. And it's hard to improve on it in an old monolithic application where we don't have React or anything, and it's not that easy to get it in the old system. Second part was SEO, because it wasn't optimized on SEO. Once again, you can also do that in the old system, but it's hard. It's easier if you have a dedicated application. Especially, honestly, most front-end developers don't want to work in a huge Java-based monolith. So it's easier to hire if you have a front-end application somewhere else. And what actually also was an argument to do this were the DORA metrics, meaning why are we so slow? Why can't we deploy as often as we want? Because our monolith is deployed 2 times a week, and we cannot easily increase that. And product people want to change buttons and stuff like that more than 2 times a week. Moving out the front end enabled us to do so. What happened next? Next part is, okay, we have the front end out of it. Now we have to move the back end. And what we cut out was the part, let's say, the most juicy part once again. And the most juicy part is the actual search, because there you can do nice things. In our case, we decided previously it was an integrated search. Now we buy something. Because if we buy it software as a service, we can buy something that's more cool than we had. So there was improvement possible by moving that. How did we do it this time? Or not how, let's start with why did we do it, because that's how my notes are. Once again, the old search had a bad quality, so we can improve by using a better search. Yeah, nice. Second argument, the old search was slow. Okay, software as a service is faster. Last argument, nobody wanted to work on that old system anymore. So actually it wasn't impossible to optimize the search, but everybody says, I don't want to. And so nobody did it. How did we go that step in this case? Not page by page or something. I wouldn't know how to do that with a search properly. But spike-based, meaning we took 3 developers, one of every team somehow connected with search, put them in a room for 2 weeks. I was one of them. Either you have it done in 2 weeks and it's running, or we stop the whole thing. Because that's what's able for business. Yeah, okay, for 2 weeks, 3 persons, fine. Let them do what they want. Either we have something cool that brings value afterwards, or we have just wasted 2 weeks for 3 people. That was the way how we were able to convince that we can do that move. And yeah, if you close the door behind 3 senior developers, it usually works out that you get something running. You have, obviously, you have some pitfalls afterwards. So no, after 2 weeks, it's not perfectly fine, but it's running and people are convinced. In our case, it worked. So this is also a helper for argumentation, how to start things. If you believe that you can get something running in like 1 week or 2 weeks, just ask for that time slot, because it's more calculatable than I want to redo everything. And I might need years. Yeah, okay, that was how we did it. So let me already come to the end of this talk. With a quote that's more philosophical now, because actually that's where I was starting with the whole topic, and that's also kind of where it ended for me. So the most important characteristic of high-performing teams is that they are never satisfied. They always strive to get better. Means for me, it doesn't really matter how bad your situation is right now. It's only important that you try to change it. You don't have to aim for the perfect goal. If you get 10% better, it's already 10% better. If you're already close to perfect but can still get 10%, it's still 10% better. So the most important part is just move in the right direction, whatever that direction is. And it's in the talk title, I started with how to convince other people. And for me, that sounded like it's us against them. And it's also often how I perceive the discussion. Developers are frustrated by the situation. I'm also sometimes frustrated by ugly applications. And then it's like, those people don't allow me to change that. But it's actually not a good way to go there, because it's not us versus them. In the end, we have the same goal. In the end, usually we work at a company or we own that company, and all of us want to have a job. And for that, the company needs to run at least fine, because that's how capitalism works. So we have more or less the same goal, and we are sitting in the same boat. The only thing is, often enough, business people do not see the sharks where we see them, so we have to tell them. And we have to help to navigate to the right place. Thank you. Any questions? I know there are a few minutes left, so I believe we are too early for beer. I see one.
Regarding data migration, did you do a data migration? And if you did you slice it?
Sorry, I didn't get the word in the middle.
Data migration?
Yeah, we did.
And did you slice it? Did you do it all in one go, or did you have it in stages? How did you manage it?
How to answer that in a way that it's also helpful for you. So we had it with a search use case, and search index building is mostly about, okay, do the new setup and set up the clients on the new system, and at some point just kill the old version. So in that case, it wasn't too hard to solve. Search indexes are not the base data that you have to migrate. They are mostly aggregated data out of something else. But we can also have a chat about how to do it in a, let's say, normal use case where you really have to migrate the base data. I see one more hand. So actually, I would also be happy if we can have that at a beer.
Hi.
Yeah.
Can you hear me? Yes.
Yeah, all fine.
Thanks a lot. It was really interesting. Coming back to the graph of the complexity versus number of size versus number. What do you think of serverless?
Yeah, I do. Let me see if I can get back early on to that graph. You mean that graph?
Yeah, exactly.
I thought about putting names on the scale. I thought about it very often, so this one is obviously what everybody calls monolith. I didn't put it there, but this is what everybody says. This is what the people who like microservices call microservice, and the people who don't, not. And then you have more or less a swear word of nanoservice. This is obviously the one on the left. I didn't put it because I didn't want to define it. Serverless, this is now the gut feeling. Somewhere in that area, depends how you do it. If you put big or proper chunks, it's more close to the island. If you really put your small 3 lines somewhere, more looks like a nanoservice. Depends on how you do it.
The thing is like, how much compared out of the process?
Yeah.
Thank you.
And once again, the answer is always, it depends. I'm sorry. No more questions? Cool. Then once again, thank you for listening and hope to see some of you at the beer.